Looking here at now factoring a third degree function here on page 134, question 5a. The first thing I'm looking at is what are the factors of our constant. So in this case, that's plus minus 2, plus minus 3, plus minus 1, and plus minus 6. Now off camera, I actually just used negative 2, and the remainder wasn't 0, which means that negative 2 is not an answer. So now, to try another one, I'm now going to use positive 2. So now we're going to look at the function at positive 2, or in other words, 2 cubed minus 6 times 2 squared plus 11 times 2 minus 6, which is 8, minus 24 plus 22 minus 6. I can see that these equate to negative 30, and this equates to positive 30, so this is going to equal 0. Which tells us that one of the factors is x minus 2. Now, I'm going to synthetically divide our original function by x minus 2 in order to get our next function. So now, I'm just going to go, 2 here, and then I'm going to put our coefficients. So 1, negative 6, and then 11, negative 6. So I'm just going to simply drop this down and get 1. 2 times 1, we get 2, so negative 4. Negative 4 times 2 is negative 8, which means this is 3. And then finally, 3 times 2 is equal to 6, and this just equates to 0, which means that we can now write x cubed minus 6x squared plus 11x minus 6 as x minus 2, and then x squared minus 4x plus 3. So now, once we have it to the second degree, we can pretty easily factor this into x minus 3 and x minus 1, which means that our factored form is going to be x minus 2, x minus 3, x minus 1 is equal to p of x. So which means that our factor values is just x equals 1, 2, and 3. And a quick way to check your answer is to make sure that if you multiply all of the coefficients of x, that you get the original, which in this case is pretty easy because it's just 1 times 1 times 1, which is equal to 1. So we are good there. The next thing is to look at our constants and make sure that they multiply to the original. So negative 2 times negative 3 times negative 1 does equal our negative 6. So that's good to go as well. So now we can be confident in our answer. That's all for this one. If you're looking for any personalized or one-on-one help, you can check the link below.